Hi guys, today we're going to go over how to find the average value of a function. A way long time ago, you hopefully learned how to find the average value of a finite number of values. It's also known as the mean. That's where your y average is equal to the sum of all your y values divided by the total number of y values. You know how to calculate mean. Now you might be asking, mean is easy. But today we're going to teach you how to calculate the average value of an infinite amount of values. I'll explain.
Okay, here's our first example. We're going to try and take the average temperature during the day, but instead of taking just 4 different temperatures, we want to take the infinite amount of temperatures throughout the day. So say 1 every minute, a temperature every 30 seconds, a temperature every second. It can go up to infinity. So to find the average temperature during the day, if an infinity amount of temperatures reading are possible, we're going to graph it like the following graph. The black curve is the curve of the average temperature change. The red line is the T average temperature over the hours. In general, let's try to compute the average value of the function y equals f of x, where x is between a and b. We start by dividing up the interval a to b into equal subintervals, each one with a length of the change in x is equal to b minus a. So if 12 was b and hour 6 was a, the change in x would be 6 hours. Next, we're going to choose points. So x1, x2 to x of n in a successive subintervals, and then we're going to calculate the average number by plugging them into the formula. So you'll plug your point x1 into the function of f, and so on and so forth. Since the change in x is equal to b minus a over n, we can rewrite n as b minus a over x and put it into our formula here. Above it, we have the function of x1 plus the function of x2 and so on and so forth until you get to the function of x of n. All of that over what we replaced for n is b minus a over the change of x, which can be simplified to be 1 over b minus a, and then you plug this all in. So this is the function of x times the change of x plus all the way to the function of n times the change of x. Simplified even more, and this is what you'll use, is 1 over b minus a. Plug it all in to the f of x of I, where I starts at 1 and goes to n, times the change of x. Okay, here's where we start getting into our infinite values. If we let n increase, we will be computing the average number of large numbers of closely spread values. For example, we would be averaging temperature readings taken every minute or every second or even every half a second. There really is no limit. So our limiting value would be infinity, which by definition is the definition of a definite integral. So we go from the limit of n to infinity, 1 over b minus a, function of x of I, where I starts at 1 and goes to n, and times the change in x. That can be written as a definite integral as 1 over b minus a from a to b, function of x, and the antiderivative of the function of x. So to find the function average, your formula is 1 over b minus a to b function of x, the antiderivative of the function of x. All right, here's our example. F of x equals the cube root of x with our boundaries at x1 and x equals 8. So here is a little graph that kind of represents what we're trying to figure out. The black solid line is the function of the graph. Our boundaries are set at 1 and 8, which is the dotted vertical lines, and we're trying to find that solid red line, which is the function average of that graph between the points 1 and 8. Okay, now that we kind of know what was going on with the graph and with our function, we're going to plug it into our f average formula. So 1 over b minus a, our b would be 8, and our a would be 1 because those are our boundaries. Then we're going to plug in our function of x, which is cubed root of x, and then dx. The next step before we start doing the antiderivative of the function of x, I simplified down our equation. So it's 1 over 7, and then the function of x can be rewritten as x to the 1/3 dx. Okay, so now we've simplified it even farther and taken the antiderivative of the function of x. So that leaves us with 1 over 7 with our boundaries. A is 1 and b is 8, so I plugged those in. The antiderivative of x to the 1/3 is x to the 4/3 over 4/3, which can be simplified into 3x to the 4/3 over 1/4, and then the rest is still the same. This is what we're going to use to solve the rest of the equation. Okay, so all I've done so far is I plugged back in our equation that we just found that was written in red right here. So our next step is we're going to plug in b, and then we're going to plug in a, and the answers that we get for each of them we're going to subtract, and that will give us our function average. So we're going to start by plugging in 8 to our original function. So that gives us 1/7 times 3x is 8 to the 4/3 over 4. A cool trick that you guys might not know, or you may or may not, to make this a little bit easier, you're going to take the cubed root of 8, which is 2, and then put it to the 4th power, which is 16. So that's just kind of a quick, easy way to do fractional exponents. So that can be simplified to 3 times 16 over 4, which is 48 over 4. And then you can't forget that you have to multiply the whole thing by the 1/7 out front. So I brought that over here. And then when you multiply them together, you get 48 over 28. And we're just going to leave that not simplified for now. Next, we're going to plug in 1 for a. When you plug in 1, you get 1/7 times 3 to the 1 to the power of 4/3. And the cubed root of 1 is 1, to the 4th power is still 1. So we get 3 times 1 over 4, which is 3 over 4. Can't forget the 1/7 from out front, so we bring that all the way around over here. And you get 3/4 times 1/7 equals 3 over 28. Okay, now that we found the values for b and a, we're going to solve. All we have left to do is subtract the value that you found for b minus the value you found for a, and that will give you your function average. So we're going to plug in the value that we found for b, which is 48 over 28, minus the value we found for a, which is 3 over 28. And that's really nice that they have the same denominators, and that's why we left them not simplified. And that gives you 45 over 28. And 45 over 28, what we found is that function average value between those 2 points of this slope. Ta-da! Okay, so that is all I have for you guys today for finding the average value of a function. Feel free to rewind the video, watch it a few times. Make sure to use the formulas that we wrote in red and just plug in your problem into that formula and work through the steps that we did, and you should be able to find your average value of function. If not, your book is always a great resource, and there are lots of other helpful videos out there. Good luck!